Welcome to qnawire.
In this problem, we're going to talk about parallel plate capacitors. So consider that we have a parallel plate capacitor that has a capacitance C and is connected through a potential difference V. Then the charge Q of this capacitor in each plate of the capacitor is equal to C times V. Also, C for a parallel plate capacitor is equal to the dielectric permittivity um, epsilon times the area of each plate divided by the separation d between the two plates. And in our problem, we have a parallel plate capacitor that has a capacitance of 5 microfarad and is connected to a battery that has a potential difference of 12 volts. And then the battery is disconnected and some experiments are done. So first, in question A, our goal is to find what would a voltmeter read just as the battery is disconnected, given that the charge of the parallel plate capacitor doesn't change. Well, if the charge doesn't change, then since V is equal to Q divided by C, Q is the charge, C is the capacitance, and neither Q nor C changes, then the voltage, the potential difference will be the same, will be 12 volts. Then in question B, we have to assume that D is doubled. So D prime is equal to 2 times D, and everything else is kept the same. Notice that the parallel plate capacitor is equal to epsilon times the area divided by D prime. So this is epsilon times the area divided by 2D. So this is the capacitance divided by 2. So C prime is C divided by 2. Well, the voltage, the potential difference, is equal to Q divided by C prime. So V prime is Q divided by C prime. So this is 2Q divided by C. Now, Q divided by C is the original the original potential difference, which is 12 volts. So it's 2 times 12, and that is 24 volts. And in question C, we have to assume that the radius of the capacitors are doubled. So the capacitors are actually circles, or discs. D is kept the same, but the radius is doubled. So R prime is equal to 2R. Remember that the area is equal to pi times the radius squared. So the area is equal to pi times 2 times the original radius squared. And this is 4 times the original area. So the capacitance, C prime, is equal to epsilon times 4a divided by d. This is 4 times the original capacitance. Okay, so C prime is 4c, and V is Q divided by C prime. So this is Q divided by 4c, and Q divided by C is V, so this is V divided by 4. Since V is 12 volts, and we have to divide it by 4, then V prime is 3 volts, which is the answer to our exercise.